For this problem, we're given a table and then a series of questions based on that table. So let's just get started. The first question says, what is the probability that someone is from the U.S.? So based on that table, what is the probability that someone is from the U.S.? Now this problem is just a simple probability, right? And how do we get the probability that someone is from the U.S.? Well, we have to start by looking at the total number of people considered. And the total number of people considered is actually 88. It's this little one here in the right corner. So there are 88 possible people considered in this table. Now, what is the probability that someone is from the U.S.? Well, now we have to look at the people from the U.S., and that becomes our numerator. So we say that the probability that someone is from the U.S. is 42 out of 88. Or if we divide both of them by 2, right? Both the numerator and the denominator can be divided by 2. That gives us 21 out of 44. Plugging that number into the calculator, we get approximately 0.47727, etc., etc., etc. I would go to at least 4 decimals since nothing was stated, so to 4 decimals brings us to here. So that means the probability that someone is from the U.S. is 0.4773. That ends the first question. Let's see about the second one. In the second question, we're asked, what is the probability that someone has at least 2 children? All right, so let's go back to our table. What is the probability that someone has at least 2 children? Well, again, how many total people are we considering? Well, there's 88 total people, so that's our denominator. And the probability that someone has at least 2 children, well, that means we want to look at the probability that someone has 2 children or the probability that someone has 3 plus, right? In both of those cases, someone has at least 2 children. 12 plus 31 gives us 43 total. So that means there are 43 people with at least 2 children. 43 divided by 88, so throw that into our calculator again. 43 divided by 88 gives us approximately 0.48866. Again, I'm going to go to 4 decimal places, and I'm going to put in 0.4886. This is the probability that someone has at least 2 children. Let's move along and look at the third question. What is the probability that someone is from the U.S. and has 1 child? When we see that word and, this means that our probability has to meet both of these conditions. We can think of and as intersection in set theory, right? So we are looking for someone that both is from the U.S. and also has 1 child. All right, let's start with our probability fraction. So we have 88 total people to choose from. And from those 88 people, we are looking for somebody that is both from the U.S. and at the same time has 1 child. And notice that's 20 people, right? 20 people are both from the U.S. and also have 1 child. So our numerator is going to be 20 divided by 88, or again, if we divide top and bottom by 2, actually 4, right? We could divide numerator and denominator by 4, and that's going to give us 5 out of 22, and plugging that into our calculator will give us an approximation. So 5 divided by 22 is approximately 0.227272, etc., etc., etc. And we are going to round to the nearest 4th decimal place. And so I'm going to place 0.2273 in my answer box. Moving on to question 4. what is the probability that someone is from the U.S. or has 0 children? This time we're talking about someone that meets one or the other condition. We're talking about a union, right, when we think of set theory. So when we talk about a union, to find the probability that someone is from the U.S. or has 0 children, we have to consider both cases, right, and add them up. Do you remember that rule when we talked about before if you have something or the other? So I'll actually write it out. The probability of A or B is equal to the probability of A plus the probability of B minus any intersection that occurs. So the probability of A and B occurring. All right, that's one way we can look at it. The other way we can look at it is again use our chart, and let's count all the situations. So what is the probability that someone is from the U.S.? Well, let's see. Our denominator is going to be 88 again because there are a total of 88 people. Now, if they're from the U.S., that means they're going to fall in this first row right here, right? If they're from the U.S., they have to be over here. And that means I have a total of 42 people. So in my numerator, I'm going to have 42 people for sure from the U.S. I'm going to add to that the number of people or possibilities of 0 children. So 0 children is this guy right here, 13. So there's 13 possible people that have 0 children. Now we have to subtract off any intersection because we don't want to double count. And double counting means we've counted it twice, right? And if we look, there is a place where our row intersects our column. Do you see this number here? 2 got counted twice. It first got counted from the U.S. part, and then it got counted from the 0 part. So we need to take off one of those countings. So we're going to subtract 2. That just gives me my probability then, right? 42 plus 13 is going to be 55, and 55 minus 2 is 53 out of 88. That probability is approximately 0.60227727, etc., etc., etc. We're going to 4th decimal place, so that's going to be 0.6023. And that's the 4th question. Moving on to question 5. Given that the person is from the U.S., what is the probability that they have 3 or more children? Right away, that word given is a clue, and that tells me we have conditional probability going on. We have a condition that we have to consider. And when you have a condition that you have to consider, that's going to affect our denominator when we're doing probability, because it narrows down the people that we're considering. Specifically, we're looking for the probability that an individual has 3 or more children, so 3 plus children, given that the person is from the U.S. And again, that given part is going to help us get a new denominator. All right, so let's take a look first of all. Because we're told that the person has to be from the U.S., we're going to focus right there simply on that row, all of the people from the U.S. So our denominator is the total people from the United States, which is 42. Now, given that they're from the U.S., what percentage have 3 plus children? Well, now we look under the column 3 plus, so our numerator becomes 13. If we take 13 divided by 42, we get an approximate answer, and I'm going to put it right here because I'm running out of some room, of 0.30952,381. That's 13 divided by 42, 0.30952,381. Going again to my fourth decimal gives us 0.3095. That's the probability that given someone is from the U.S., they have 3 or more children. And this brings us to our final question. Given that the person has 1 child, what is the probability that that person is from the U.S.? So we have another conditional probability clued in by the word given. So we are looking for the probability that the person is from the U.S., so the probability that someone is from the U.S., given that the person has 1 child. And again, we focus right in on the given part because that is going to restrict our denominator. We know that the person has 1 child. So looking in our chart or our table, we see that we are narrowing in on this column right here. Because the person has 1 child, we know the total possible people that can be involved in this situation is 32. So that becomes our denominator. Now, based on the fact the person has 1 child, what is the probability the person is from the U.S.? So now we select the people from the U.S. that we can consider, which is 20. So the probability that the person is from the U.S. given that they have 1 child is 20 divided by 32, or dividing both numerator and denominator by 4 gives us 5/8. Pulling out our calculator, we get 0.625. And that's actually an exact number, so I don't have to worry about rounding. 0.625 is my final answer. That's the probability for that last question. Now, that was a long problem, but hopefully this all made sense. If you have any questions at all, please don't hesitate to reach out and contact me.